Good.
Yeah.
Hey everyone, we're Team Allan Equipment. I'm Allan.
I'm Ashad.
I'm Stuart. I'm Ali.
And I'm Wesley.
And me and Ashad are responsible for the electrical design as well as the coding of the prototype.
And myself, Ali, and Wesley are responsible for the mechanical build of the prototype.
Okay, 3, 2, 1.
So this is a system we came up with. Let's talk about the problem Allan Equipment faces.
Allan Equipment is located in Govit, PEI, and they are the largest designer and manufacturer of potato harvesting equipment in Canada. They have a 120,000 square foot facility, which they've been using to serve the local agricultural industry for over 60 years. They're located in Govit, PEI, and you can see their facility right here in Figure 1. So, the problem. Currently, the machine that they use involves an automated process which has fixed blade spacing to cut the potatoes. You can see that right here in our figure. So the lack of alignment in this process causes an 8% loss of potatoes, where the main issue is caused due to potato ends being cut too short, which results in the loss of valuable eyes. As you can see here in the video, the potatoes getting cut don't often go in properly. The ends are being cut too short.
The team is planning to achieve this by reducing the potato waste to less than 4%, maintaining a cut rate of at least 20 cuts per second, providing accurate cuts within plus or minus 10% of the target range, cutting potatoes along their length, and including integration with CAN bus connectors.
So here we have our mechanical build. What we've done is created two V conveyors. They're powered by 0.35 horsepower motors, 10-to-1 gearboxes. So the potatoes are placed onto the conveyors and then run through the system. And in between the conveyors, we have a blade attached to a 1 horsepower motor and a 5-to-1 gearbox. And this is a double-edged blade, and as it rotates, it cuts the potatoes as they go past. And with the control system that is on,
we have our 208 volt 3-phase input that goes into the electrical panel. This is the disconnect that turns on the panel. In here we have all of our drives that control the motors and the blades, as well as our power distribution blocks, our encoders, connections for encoders, as well as the screen. And in case of an emergency, there is an e-stop that is also connected to the screen.
So we've got our screen here which integrates the control for all the motors with the code through CAN bus communication protocols. So as you can see here, once I turn off the e-stop and I hit run, we can go into manual mode here, and I have control for each motor however I'd like to control it, whatever speeds and whatever directions. This would help us analyze if anything went wrong. And we have the automated cutting algorithm where, as you can see here, I set the lengths that I would like the potatoes to be cut at. I determine a cut rate, for example, say 3 cuts per second, and then I just have to hit start.
So let's take a closer look at how that cutting happens in one of our test videos.
So from the video, the machine can cut potatoes at high speed accurately. However, issues lie on positioning the potatoes, as sometimes the potatoes jumping between the conveyors, especially at high speed, which causing issues within the system.
To fix this, we are planning to add a potato positioner in between the conveyor gaps in order to hold the potatoes during position. Thank you for listening, and we hope to see you guys at the Expo April 22nd.
Thank you.